Hi folks, welcome to the channel and the second episode of the electric dirt bike build. In the previous video, I showed you the CAD for this bike and went over the design details, and I wired up and bench tested the 10 kilowatt brushless motor and controller that Golden Motor provided for the project. If you haven't seen that video yet and want to get up to speed, I put a link for it in the video description below. In this video, I'm going to build the trellis tube chassis and suspension, and I first started by taking measurements from the CAD and drawing the center lines for all the tubes that need to be bent in full scale onto a large piece of building paper, so I could use them for reference when bending and cutting the tubes to ensure accuracy. Next, I cut and milled the head tube and bearing housings for the swingarm pivot bar, which also serves as a jack shaft for the two-stage chain drive. Instead of boring out a solid bar for the bearing housings, I just welded a plate on one side of the tubing to form a stop for the bearings to rest against. Because my hole saw isn't exactly the same size, there's a bit of a gap to fill, which I first bridged using a series of tack welds using my Arc Captain Flux Core MIG welder, then finished with my Xphotonics X1 Pro laser welder, which doesn't fill large gaps very well, but it can produce solid, deep penetrating welds that can mimic a TIG, and it looks a lot better than a flux core bead. With the head tube and bearing housings finished, I pressed the bearings in place and installed everything on a 1-inch chromoly shaft with temporary spacers that I 3D printed and will be replaced later with stainless steel. It's generally not a good idea to press on the inner race like this when installing a bearing and a housing, but I didn't have anything on hand that would fit inside the tube and match up with the outer race just right, and it didn't take a lot of force to press in place anyway, so it should be fine. Next, I rough cut the 1-inch DOM tubing for the frame and cleaned the mill scale off using a belt sander. The wall thickness for this tubing is 0.083 inches. Then I used the reference lines that I drew earlier to mark the start of the first bend on one of the top main tubes, and then clamped the tube in my rotary draw bender with the reference mark for the start of the bend placed at the start of the 3-inch radius die in the bender. Then I made sure the tube was properly seated in the follower before setting the angle pointer and bending the tube. Because steel is flexible, there's some level of springback that comes with bending steel tubes, which will be more or less depending on the size of the tube and its wall thickness, and it needs to be compensated for when bending. For this tubing, I'm bending it almost 2 degrees beyond my target angle so that it springs back to exactly where it needs to be. With the first bend done, I repeated the process for the subsequent bends, using a center reference line drawn on top of the tube to help keep it lined up properly in the bender. The last bend at the top aims the tube to connect with the head tube, so it needs to be bent in 2 directions with this one bend, known as a compound angle. To do this, I place the tube in the bender and clamp this 3D printed magnetic jig to the tube, using the reference line to center it up. Then I placed this digital finder on the jig and twisted the tube to set the previous bends to 23 degrees from horizontal, which was determined from the CAD, and this created the compound angle that I needed for the last bend. After the top tubes were bent, I moved on to bending the bottom tubes, which were pretty much the same, except one end wraps around the bottom of the motor to join up with the jack shaft. Next, I set up my custom bike chassis jig to accommodate the geometry. With this, I can use the bottom beam and end posts as level and plumb benchmarks to set the head tube, jack shaft, bearing housings, and any other component exactly where they need to be for welding, and it just makes the build process a whole lot quicker and easier. I have a build video for this jig as well, which you can check out at the link in the video description if you're interested. Free plans are also available. Because coping tubes with compound angles can be a little tricky, I opted to use the CAD to create 3D printed templates of each notch, which were made as sleeves that slip over the tube and have reference lines to match up so the notch can be traced exactly where it needs to be and to an exact profile for the tight joints that my laser welder prefers. A tube coping tool like this is also pretty handy to have. It's a bit rougher to trace around, but it still provides a good profile to follow. Again, because I don't have a hole saw that matches the head tube or bearing housings, I chose to notch the tubes with an angle grinder instead of my tube notcher. I prefer to use a 40-60 grit flap sanding disc for this because I find I have better control and accuracy than with a grinding wheel. Once the main tubes were notched, I held them in place on the jig with magnets and tack welded them with the laser welder. To save wasting time and material, I won't weld anything complete until all parts are tacked in place and the hardware is installed to make sure everything fits properly first. Having everything tacked in place first also helps reinforce against warping and distortion that can happen when welding continuous beads on unsupported material, and it allows me to plan a welding sequence that's actually beneficial instead of potentially destructive. The last thing I want after spending all this time building a chassis is to have components warp or bend out of place or put themselves under stress. After the main tubes were in place, I changed some fixtures on the jig to prep for building the swing arm. Then I started making the dropouts for it from 3/16 inch thick steel plate. Next, I clamped the dropouts in the jig and started bending and notching the main tubes for the swing arm. Once the main tubes were in place, I wanted to build and fit the progressive dampening linkage for the rear shock because it's a really tight space and I wanted to make sure the rest of the tubing provided enough clearance for it. With the PDS linkage installed and confirmed to work, I went back to welding the rest of the tubing for the swing arm and chassis before building the subframe for the seat. The triangulated braces are made from 3/4 inch DOM with 0.083 inch thick wall. After everything was tacked in place, I installed the front forks and wheels and then weighed it for curiosity's sake. The 735mm front forks and 19-inch wheel that I installed were actually sized and purchased for the original smaller version of this bike that I had planned, so they're a little small for this one, especially compared to the 18-inch rear wheel. Currently the ground clearance is only 11 inches and the rake angle dropped from 26 to around 25 with the smaller components. But I do have a 21-inch front wheel and 800mm forks coming to replace them, which will provide a smoother ride and increase the ground clearance to around 12 inches, and the rake angle to around 27 degrees so the steering isn't too sensitive. So far the bike weighs in at around 102 pounds, or 48 kilograms, which is right around where I hoped it would be. With a 37-pound motor, 30-pound battery, controller, seat, wiring, and a bit of plastic, it should top out at around 200 pounds, or a bit less if I'm lucky. But that's it for this video, folks. In the next episode, I'm going to finish installing the rest of the hardware for the motor, controller, brakes, and so on, and get the frame welded up and ready for finish. I'm not sure if I'm going to paint or have it powder coated yet. I'm leaning toward powder coating, but if I do, I'll probably get a kit and set up a space here to have a go at it myself. We'll see. Until then, if you have any questions, then post them in the comments below, or check out the first episode if you haven't seen it yet. I also put links in the description for the motor and controller that I'm using, in case you're interested. Thanks for watching, and take care.